Thank you for joining another math lesson hosted by Book&Table. I am your math tutor, Maurice Wright, and in this chapter, we are going to review functions. We'll review how to evaluate functions, including piecewise functions and functions placed in a table or on a graph. We'll review the composition of functions, as well as how to combine functions using basic operations. We'll take a look at how to sketch functions, including piecewise functions. And then we'll wrap up the chapter by reviewing how to find the domain and range of particular functions. Should you have any follow-up questions, feel free to leave them in the comment section. Or you can contact a tutor in your neighborhood by visiting bookandtable.com or by downloading our app on the App Store. So let's start the chapter by reviewing relations. Ordered pairs are two numbers written in a specific order, the x-coordinate first, the y-coordinate second, and can be used to show the values of a point on a graph. A relation, in this case denoted with the letter R, is a set of ordered pairs. So we have three ordered pairs here, and we see that the first number in each pair represents the x value, or the x-coordinate of the point, and the second number in each pair represents the y-coordinate, or the y value, for each point. And the reason this is important is because a function is a relation in which each x value has one y value associated with it. So in this case, we have the relation h, and we see we have 4 points in this relation. Now the x values are considered our input values. They're the number we plug into the function. And the y value is considered the output. And we'll discuss this further a little bit later in the chapter. But we see here for our 4 points, we have x values of -3, -2, -2, and 0. And for our y values, we have 5, 2, 0, and -2. So we have -2 twice for our input values, and each -2 is associated with a different output value, 2 and 0. So since this input, -2, can provide two different outputs, that lets you know that h is not a function. Now, let's review a few different types of functions. A linear equation is a function because there is only one y value for each x value. So here's an example of a line. And a line in general has the basic equation of y is equal to x. They both have an exponent of 1. And again, a line will look different on a graph based on the slope or constant added. But the general formula is y is equal to x. And you get a straight line through the graph. And for each x value, there's only one y value associated with it. A parabola that opens up or down is a function because there's only one y value for each x value. The general formula for a parabola that opens up is y is equal to positive x squared. And we see for each x value, there's only one y value associated with that x. If you go up and down, there's not another y value associated with that point. If we flip this parabola upside down and now it opens down, we can use a vertical line again to find if there's a second y value associated with each x. So at this point, there's only 1 point above or below. At this point along the curve, there's only 1 point here. At this point of the curve, this is the only point. If we go up or down, we don't find another y value associated with this x. But in the case where the parabola opens to the left or right, it is not a function because there are two y values for certain x values. So the general formula for parabolas that open to the side is x is equal to -y squared. And now when we draw a vertical line, we see that for this x value, we have 1 and 2 y values. So since this vertical line can cut through two different parts of the curve that lets you know this is not a function. Same thing at this x value. We have a y point here and a y point above here. If we flip this parabola to the right, the general formula is x is equal to y squared. And again, a vertical line shows us that for certain x values, we have multiple y values associated with that x. Have a y value down here, and we have a y value up here. Another example is a circle. A circle is not a function because there are two y values for certain x values. The general formula for a circle is x squared plus y squared is equal to r squared. And if we use a vertical line, we see that for certain x values, you have multiple y values associated with it. Go to this x point, we have a y value here and here. So we see a circle is not a function either. So we notice that a vertical line can be used to help us figure out if a curve represents a function or not. If a vertical line can intersect more than one point on the curve, then the graph is not a function. Very important. We'll be utilizing this throughout the entirety of this chapter. Let's now take a look at explicit versus implicit form. Explicit form of a function is written in terms of an independent variable, in this case our x, with the variables on opposite sides of the equal sign. So we have y, which is equal to f of x. So y is the result of plugging x into the function f, and x is our independent variable. But we can also have y is equal to f of x, which is equal to x plus 2. So we plug in a value for x, and the output will be y. This is explicit form. Our y and our x are on opposite sides of the equal sign. This would be another example. F of x is equal to 3x minus 5. And f of x represents the y value at a specific x value. So this is explicit form. Implicit form of a function is written with the two variables on the same side of the equal sign. So 2y plus 3x is equal to 5. We still have the same variables, but now the x, instead of being on the right side, is on the left side, along with our second variable. So that is the difference between explicit and implicit form. Let's now begin discussing how we go about evaluating functions, and we'll begin by discussing function notation. Function notation is the way a function is written. A function can be represented by any letter, but the most popular function notation is f of x. So when we are dealing with functions, we choose a letter to represent that function, and beside that letter, we have a pair of parentheses with a letter inside of it. The letter inside of the parentheses represents the independent variable for the expression. So the value of the function will be based on the number or expression that you plug in for this independent variable. Now we state this function as f of x, but both the letter representing the function and the letter representing the independent variable can be changed. So we can also have m of x, and now this function is represented by the letter m. We could change the letter representing the function or the independent variable itself. So this would be called h of k. But this doesn't change how you go about evaluating the expression, since you know the letter inside of the parentheses represents the independent variable, and the letter to the left of this represents the letter for the function. Okay, so just keep this in mind. Now, notation shows the y value associated with a specific x value of a function. So let's say we had a coordinate plane with this function in it. F of x is equal to x plus 1, which is equal to y. So if this is our function, the input is the letter inside of the parentheses, which is x. That's our independent variable. So when you plug in a number for x, you'll get an output that correlates to this expression here, x plus 1. and the result of that expression will give you the y value associated with that specific x value. So let's say we plugged in -1 for x for this expression. That means the function has a value of 0 along the x-axis where x is equal to -1. So you go to -1 along the x-axis, and the function has a y value of 0. And this can be expected since the function had the expression x plus 1. So -1 plus 1 will give us 0. Let's say we plugged in a different number for our x. If we plugged in 0, that would give us 0 plus 1, which gives us an output value of +1. So at 0 along the x-axis here, the origin, we see the function has a y value of +1. Let's say the input was +1 instead. The output would be equal to 1 plus 1, which is a y value of 2. So we go along the x to +1, and we see the function has a y value equal to 2 here. So this is the general process of evaluating a function. Now, evaluating a function means substituting a number or expression into the function for the independent variable. So let's say we had the function f of x is equal to 5x plus 6, and you were asked what is f of 3 equal to. What this question is asking you is if you go to 3 along the x-axis, what is the y value associated with this specific x for the function? So let's dive a little bit deeper into how we go about evaluating functions. Let's say you were given f of x is equal to 5x plus 6, and you were asked what is f of 3 equal to. You could also be asked what is f of x plus 1. The input does not have to be a numerical value. It can also be an expression. And the function itself will wind up changing, since we don't simply have x inside of the parentheses, but we'll take a look at this in a second. Let's start by substituting a number into the expression. So if we're evaluating a function substituting a number, the first step is to substitute the number inside of the parentheses for x. So we were given f of x is equal to 5x plus 6. So we want to substitute the number inside of the parentheses, which would be 3, in for x. When we do so, that gives us 5 times 3 plus 6. And now, step 2, we want to simplify the expression. So 5 times 3 is 15. And 15 plus 6 is equal to 21. So we see f of 3 is equal to 21. So when you're given a function and a number is substituted in for the independent variable, you substitute that number in for x, and then you simplify the expression. But what do we do if we're substituting an expression instead of a number? Step 1, substitute the expression inside of the parentheses for x. So again, our function is the same. F of x is equal to 5x plus 6. But now inside of the parentheses here, we have x plus 1 instead of x. So we substitute x plus 1 everywhere we see x in the expression. So we get f of x plus 1 is equal to 5 times x plus 1 plus 6. Instead of x here, we have x plus 1. And now, step 2, simplify the expression. So we want to evaluate this term here first. So we have 5 times x, which gives us 5x. And 5 times 1 will give us 5, plus 6. And now we want to add 5 and 6 to give us 11. So we see f of x plus 1 is equal to 5x plus 11. So when we substituted a number in for the independent variable, the final result, the output, was a numerical value. But when we substitute an expression into the independent variable, we wind up with an expression as the final result. So the outputs will be different whether you're substituting a number or expression. So just keep that in mind. But now that you've had a chance to see an example of both, let's now have you try a few practice questions. Given that f of x is equal to negative 2x plus 4, question number 1, what is f of negative 3? Question number 2, what is f of 5? Question number 3, what is f of x minus 2? And question number 4, what is f of 2x plus 1? Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, substitute the number inside of the parentheses for x. So the independent variable is x, and the question asks us what is f of negative 3. So we plug in negative 3, each place we see x, which is here. And now step 2, we want to simplify the expression. So we start with negative 2 times negative 3, which will give us positive 6, plus 4. So we see f of negative 3 is equal to 6 plus 4, which is equal to positive 10. So the answer to question number 1 is f of negative 3 is equal to 10. Question number 2, we have the same function. The question asks us what is f of 5. So step 1, substitute the number inside of the parentheses 5 for x. And now we want to simplify the expression. So we start with negative 2 times 5, which gives us negative 10 plus 4. Negative 10 plus 4 is equal to negative 6. So the answer to question number 2 is f of 5 is equal to negative 6. So that is the answer to question number 2. Let's now have a look at question number 3. Step 1, substitute the expression inside of the parentheses for x. So instead of a numerical value, we have the expression x minus 2. So we want to substitute x minus 2 where we see x, which is here. And now we want to simplify the expression. So we want to distribute this negative 2 to both terms inside of the parentheses, which would give us negative 2 times x, which is negative 2x. Negative 2 times negative 2 is positive 4, plus 4. And now we combine positive 4 and positive 4 to give us positive 8. So we get f of x minus 2 is equal to negative 2x plus 8. In question number 4, we have 2x plus 1 as the input value. So we want to plug that in each place we see x, which is here. And now we want to simplify the expression. So we begin by distributing this negative 2 to both terms inside of the parentheses here, giving us negative 2 times 2x, which is negative 4x. And negative 2 times positive 1 is negative 2, plus 4. Negative 2 plus 4 is positive 2. So f of 2x plus 1 is equal to negative 4x plus 2. So that is how we go about evaluating a function with either a number or an expression. Let's now begin discussing how we go about evaluating piecewise functions. A piecewise function is a function that has different equations that represent specific intervals of the x values. So here we have an example of a piecewise function on a graph. From negative infinity up to negative 2, we see it has a consistent value. And then at negative 2, we see that that value begins to change, has more of a shape of a parabola. And then when x has a value of positive 2, the function then changes to more of a linear expression. So for different pieces along the x, the function has different expressions that represent those intervals. So we have f of x is equal to 6 if x is less than or equal to negative 2. negative 2, less than, so that'd be 6. It has a value of x squared if x is between negative 2 and positive 2. And it has the expression of x plus 5 when x is greater than 2. So for each interval, you have different expressions representing the function f of x, but all three of these represent f of x just at different places along the x. The input value of the function will determine which piece of the function will be used to evaluate the value of the function, the input value being the x. So if the x were negative 3, you go to the intervals and you find negative 3, and that would be in this first section here, where it says if x is less than or equal to negative 2. Well, negative 3 is less than negative 2, so the function has a value of 6 when x is negative 3, since this would be the expression representing the function here. If the input value were 0 instead, 0 can be found between negative 2 and positive 2. So x squared would be the expression used to represent the function at 0. And if the input value were a number like 5, then you would use x plus 5 to represent the function. Since 5 is greater than 2, it would fall into this section. So remember, when you're dealing with a piecewise function, the number representing the independent variable is the number you're looking for in the intervals of the x's. This is the x value, so you're trying to find the interval that includes that x value. And then the expression associated with that interval is the expression you use to evaluate the function. Now, one more thing. The expression that includes or equal to includes the value at the limit, while the expression without it does not. So what does that mean? Here at negative 2, where we're going from one interval to a second, the circle that is filled in includes that value. So negative 2 is a part of this first interval. X is less than or equal to. So that circle is filled in. So that means here at this interval, which starts at the same number, negative 2, x cannot be equal to that value, because at negative 2, it's already equal to 6. So that is why this circle is empty. At negative 2, the expression is equal to the one that is filled in, not the one that is empty. On this side, same thing. When we get to 2, we see here x is less than or equal to positive 2. So f of 2 would be evaluated with x squared, since 2 is included in this interval. Whereas x is larger than 2 for the third interval. So 2.1 would be evaluated with this expression. 2.0 is evaluated with this expression. So let's walk through an example together. This is the same piecewise we were just looking at. So f of x is equal to 6 if x is less than or equal to negative 2. F of x is equal to x squared if x is greater than negative 2 or less than or equal to positive 2. And f of x is equal to x plus 5 if x is larger than 2. Question number 1, what is f of negative 2 equal to? Question number 2, what is f of 2 equal to? And question number 3, what is f of 7 equal to? So for this example, I want to go through several points just to show how the expression used to evaluate the function changes based on the input value. So we'll start with negative 2. So step 1, find the interval that includes the input value, which for the first question is negative 2. So if we look at the intervals, x is less than or equal to negative 2. So that's our input value. And here we see the function has a value of 6. So f of negative 2 is equal to 6, and that would be the final value of the function at this input. The second question was f of 2. So step 1, again, find the interval that includes the input value 2. So here we have -2 is less than x, which is less than or equal to 2. So x can equal 2, and when it does, we use x squared. So we plug in 2 for x, giving us f of 2 is equal to 2 squared. And now that we replace x with 2, we want to evaluate the expression 2 squared, which would be equal to 4. So when the input value changed, we changed the expression that we used to evaluate the function. And again, for the third example, we had 7 as the input. And for the intervals, we see 7 is larger than 2. So we want to use x plus 5 to represent the function f. And now we want to replace each x with 7. So that's how we get f of 7 is equal to 7 plus 5. And now that we've replaced x with 7, we want to evaluate the expression 7 plus 5, which should be equal to 12. So that is how you go about evaluating a piecewise function. Let's now have you try a few practice questions. Given that f of x is equal to x minus 2 if x is less than or equal to -3, and x squared plus 3 if -3 is less than x, which is less than 3, and f of x is equal to -4 if x is greater than or equal to 3. Question number 1, what is f of -5 equal to? Question number 2, what is f of -3 equal to? Question number 3, what is f of 3 equal to? And question number 4, what is f of 5 equal to? Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, find the interval that includes the input value -5. So we go to our intervals, and -5 is less than -3. So we want to use the expression x minus 2. So then we want to replace each x with -5, giving us -5 minus 2. And now that we have the expression we need and the number plugged in for the independent variable, the third step is to evaluate the expression, and -5 minus 2 is equal to -7. So the answer to question number 1 is f of -5 is equal to -7. Question number 2, we were asked to find f of -3. So if we go to the intervals, -3 can be found in the first interval since x is less than or equal to -3. Since x is equal to -3, we use the first expression, x minus 2, and replace each x with -3. And now we want to evaluate the expression, -3 minus 2, which gives us -5. So the answer to question number 2 is f of -3 is equal to -5. Question number 3, we're asked to evaluate f of 3. So we want to find the interval that includes the input value 3. The second interval is -3 is less than x, which is less than 3. So since x is not equal to 3 in this interval, we use the third interval, since this is where x can be equal to 3. And in this case, the expression is always going to be equal to -4. So when we evaluate the expression, we get f of 3 is equal to -4. So that is the answer to question number 3. Let's now have a look at question number 4. You were asked to evaluate f of 5. So we want to find the interval that includes the input value 5. And that would be x is greater than 3, since 5 is greater than 3. So now when we evaluate the expression here, it's always going to be equal to -4. So we get f of 5 is equal to -4. So that is how you go about evaluating piecewise functions. Let's now discuss how you would go about finding the x for a function. Evaluating a function may involve substituting a number for f of x and then finding the x value or values associated with this number or y value. So let's say, for example, we had f of x is equal to 7. So we substitute f of x with 7. And that's equal to 2x plus 3. So what is the x for this case? This is the scenario we want to take a look at. So they're telling us the y value, and we're trying to find the x value associated with that y value for this particular function. Another example, let's say we had f of x is equal to 5, and that's equal to x squared plus 4x. What is the x value here? So in this case, the number 5 along the y-axis has two different x values associated with it. So how would we find both of these? This is the process we want to examine a bit closer. So let's actually do so by walking through an example together. Let's say we were given f of x is equal to x squared plus 4x. If f of x is equal to 5, what is the value of x? So in the question, it states the function f of x is equal to 5. So we want to replace f of x in our function with 5 and then work backwards to find x. So the first thing we want to do is we want to substitute 5 for f of x, giving us 5 is equal to x squared plus 4x. And now, since we have a quadratic, we want to move 5 to the right side and then factor the expression. So we'll subtract 5 from both sides, giving us 0 is equal to x squared plus 4x minus 5. And now the third step, we want to factor the polynomial. Since the coefficient of the quadratic term is 1, we can factor this if we can find factors of -5 that have a sum of +4. So we can get to -5 by multiplying 5 times -1. And the sum of these two numbers would be 5 minus 1, which is 4. So 5 and -1 are the numbers we are looking for. So this polynomial can be changed to x plus 5 and x minus 1. And now with the polynomial factored, we can solve for the x's. So we want to set each factor equal to 0 and then solve for x. So we'll start with x plus 5. We set that equal to 0. And to solve for x, we want to subtract 5 from both sides, showing us that x is equal to -5. And we want to set the second factor, x minus 1, equal to 0. And we solve for x by adding 1 to both sides, showing us x is equal to 1. So when this function is equal to 5, x can be equal to -5 or +1. And we can check this answer by plugging each number into f of x. So when we plug in -5 into f of x, we get -5 squared plus 4 times -5 is equal to 5. Remember in the original question it said f of x is equal to 5. So -5 squared is 25. 4 times -5 is -20. 25 minus 20 is equal to 5, giving us the true statement 5 is equal to 5, confirming that -5 is one of the values for x. And now we test the second number we got, +1, giving us 1 squared plus 4 times 1 is equal to 5. 1 squared is equal to 1. 4 times 1 is equal to 4. 1 plus 4 is equal to 5. Again, giving us a true statement, 5 is equal to 5, confirming that x is also equal to +1 when f of x is equal to 5. So that is how you go about solving for the x given a particular function. Let's now have you try a few practice questions. Given that f of x is equal to negative 4x plus 1, and g of x is equal to x squared minus 3x plus 4. Question number 1, if f of x is equal to 13, what is the value of x? Question number 2, if g of x is equal to 14, what is the value of x? Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, substitute 13 for f of x. And step 2, solve for x. So we first want to subtract 1 from both sides, giving us 13 minus 1, which is 12, is equal to negative 4x. And now we want to get rid of this coefficient negative 4, so we divide both sides by negative 4, showing us x is equal to 12 divided by negative 4, which is negative 3. So we get x is equal to negative 3. And step 3, we can check the answer by plugging the number into f of x. So we want to plug in negative 3 here and see if the expression is equal to 13. When we do so, we get negative 4 times negative 3, which is positive 12, plus 1, which is 13, giving us the true statement 13 is equal to 13, confirming that x is equal to negative 3 when f of x is equal to 13. So that is the answer to question number 1. Let's now have a look at question number 2. We're given g of x is equal to x squared minus 3x plus 4. So step 1, substitute 14 for g of x. And since we have a quadratic and the variable appears twice, we want to create a trinomial that we can factor on this side. So we'll subtract 14 from both sides, giving us 0 is equal to x squared minus 3x, and 4 minus 14 is equal to negative 10. And now the third step, we want to factor the polynomial. So we want to find two factors of negative 10 that have a sum of negative 3. Negative 10 and 1 do not work since their sum is equal to negative 9, and that does not equal negative 3. Negative 5 times 2 would give us negative 10, and their sum is equal to negative 5 plus 2, which is negative 3, and that's the number we're looking for. So our two factors will be x minus 5 and x plus 2. And now step 4, we want to set each factor equal to 0 and solve for x. So we'll start with x minus 5, and we'll add 5 to both sides, showing us x is equal to 5. And now for the second factor, x plus 2, we set that equal to 0. And now we want to subtract 2 from both sides, showing us x is equal to negative 2. So the function has a value of 14 when x is equal to negative 2 or positive 5. Now we can check these answers by plugging each number into g of x and confirming the result is 14. So if we plug in negative 2 for x, we get negative 2 squared, which is 4, minus 3 times negative 2, which is 6, plus 4. 4 plus 6 is 10. 10 plus 4 is 14, giving us the true statement 14 is equal to 14, confirming that negative 2 is one of the values for x when g of x equals 14. And we can check the second answer we got, positive 5, by plugging that in for x, giving us 5 squared, which is 25, minus 3 times 5, which is negative 15, plus 4. 25 minus 15 is equal to 10, and 10 plus 4 is equal to 14, giving us another true statement, 14 is equal to 14, confirming that x is equal to 5 when g of x is equal to 14. So that is how you would go about finding the x values affiliated with a certain y value for the function. Let's now discuss how we go about evaluating a function on a graph. The graph of a function is the collection of ordered pairs in the plane. So let's say you had a parabola, f of x. This line represents an infinite number of points along that curve, right? It's a collection of ordered pairs that create this line. Now the value of f of x, the entire thing, is equal to the y value of the function at this exact value of x. So we have f of x is equal to x squared, and the y value of the function is equal to the value of the expression when a specific x value is plugged in. So why are we reviewing this? If we want to evaluate a graph for a particular x value, you go to that point of the axis. So for f of negative 2, you go to negative 2 along the x-axis. And the y value is going to be equivalent to wherever the curve is. So if you're given the expression, you can plug the number in. But if you have just the graph, you would go to negative 2, and you would go up to the curve, and that would tell you the y value for that specific x. If it were negative 1, if you have the expression, you know f of negative 1 is negative 1 squared. But if you had just the graph, you'd go to negative 1 along the x, and then go up to the curve, and then you take a look at what that y value is at that point of the curve. And we see here it's positive 1. If you had 3, you would go to 3 along the x, and you go up to the curve, find the point on the curve, and then take a look at the y-axis, and that would tell you the y for that particular x. So let's walk through an example. Let's say you were asked to evaluate f of x, and they asked you what is f of negative 1. So what you want to do, step 1, go to the number inside of the parentheses, which is negative 1, along the x-axis, so that would be here. And then step 2, go up to the function. So we wind up at this point along the curve. And now the third step, we want to go to the y-axis from here. And when we do so, we see that it has a y value of positive 5 when x is negative 1. So f of negative 1 is equal to positive 5. That is how you go about evaluating a function on a graph. Let's have you try a few practice questions. Let's say you're given this graph of g of x, and you were asked to evaluate. Question number 1, what is g of negative 7? Question number 2, what is g of 0? In question number 3, what is g of 6? Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, go to the number inside of the parentheses along the x-axis. So question 1, we were asked to find g of negative 7. So we go to negative 7 along the x-axis. And then step 2, we go up to the function. So we wind up at this point here. And now the third step, we want to go to the y-axis from here. And when we do so, we see that the function has a value of positive 7 when x is negative 7. So the answer to question number 1 is g of negative 7 is equal to 7. Question number 2, we're asked to find the value of g of 0. So step 1, go to the number inside of the parentheses, 0 along the x-axis. We actually don't have to go anywhere. It's the origin, is where x is 0. And here we see the function also has a value of 0, so you don't have to go up or down. This is the value we're looking for. And y has a value of 0 here. So we see g of 0 is equal to 0. So that is the answer to question number 2. Let's now have a look at question number 3. We're asked to find g of 6. So step 1, go to the number inside of the parentheses, 6 along the x-axis. So we go to 6. And then step 2, we want to go down to the function from here. And then step 3, we want to go to the y-axis from here, showing us that when x is 6, y is equal to negative 6 for the function g. So g of 6 is equal to negative 6. So that is how you would go about evaluating a function on a graph. Let's now discuss how you would go about evaluating a function on a table. The table of a function is a collection of ordered pairs that can be found along the curve of the function. The x value is the input and the y value is the output. So we have some function and we have ordered pairs from that function. We have the input, which is the x value, and the output, which is the y. But a lot of times for a table, the y is replaced with f of x since they are equal to each other. It is the y value for a specific x along that function. So do not let this throw you off. When you see the column with f of x, that is the same as them saying y. Okay, so you have the x coordinate and the y coordinate for specific pairs in the table. And then you'll be asked to evaluate the function based on this table of ordered pairs. So for example, the first pair is negative 2, 4. That lets you know when you go to negative 2 along the x-axis, the curve will have a value of positive 4. So f of x has a value of positive 4 when x is equal to negative 2. That's what this shows. When x is 0, y is 0. So f of x has a value of 0 when x is 0, this point here. When x is 1, the function has a y value of 1. And when the x value is 3, the function has a value of 9. Okay, so that is how evaluating a table works. Let's walk through an example together. Let's say you're asked to evaluate f of x, and you are given these ordered pairs in this table here. We'll walk through a few questions in this example. So question number 1, what is f of negative 1 equal to? Question number 2, what is f of 0 equal to? And question number 3, what is f of 2 equal to? So all of these questions are based on this table. So for the first one, f of negative 1, you want to find the number inside of the parentheses, which is negative 1, in the column with the x values. So our x is negative 1, so we go to the column with the x's and we find negative 1, and we select the y value in the same row, which is 4. So f of negative 1 is equal to 4. So what is the value of the function for this value of x? Let's take a look at another example, f of 0. Find the number inside of the parentheses 0 in the column with the x values. And then step 2, select the y value in the same row, and that would be here. When x is 0, the function has a value of 2. And just one more for good measure. What is f of 2? We want to find the number inside of the parentheses, which is 2, in the column with the x values, and then select the y value in the same row. So that would be this row here. So f of 2 is equal to negative 2. So that is how we go about evaluating a function from a table. Let's now have you try a few practice questions. Evaluate f of x. Question number 1, f of negative 4 is equal to what? Question number 2, what is f of negative 3 equal to? And question number 3, what is f of 0 equal to? Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, find the number inside of the parentheses, negative 4, in the column with the x values. And step 2, select the y value in the same row. So we go to the column with the x's, we find negative 4, and we see f of x has a value of 5 when x is negative 4. So f of negative 4 is equal to 5. So that is the answer to question number 1. Question number 2, we were asked to find f of negative 3. So step 1, find the number inside of the parentheses in the column with the x values. So here's negative 3. And then step 2, select the y value in the same row, which would be 0. So f of negative 3 is equal to 0. In question number 3, we're asked to find f of 0. Step 1, find the number inside of the parentheses in the column with the x values. So we find 0 here, and we want to select the y value in the same row, which would be negative 3, showing us f of 0 is equal to negative 3. So that is how we go about evaluating a function on a table. Let's now discuss the composition of functions. Now, the composition of functions is the process of using the value of one function as the input value for a second function. So we have some function f, but inside of the parentheses, instead of having the independent variable x, we have a second function, g of x. F of g of x can also be written this way, f of g of x. Just make sure you do not confuse this with f of g of x is equal to g of f of x. In this example, f is the outer function and g is the inner function. But on this side, g is the outer function and f is the inner function. And this does affect the final outcome of the expression. The best way to take a look at this is for us to walk through an example together. So let's do so. And let's say we were given the two functions f and g, and f of x is equal to x plus 2, and g of x is equal to x squared. We can have a composition of functions including an expression or including a specific number. So we'll take a look at both cases. But let's start by first evaluating what f of g of x would be. So when we have a composition of functions and we're substituting an expression, g of x, in for the independent variable, we first want to write the expression for the outer function. So the outer function in this case is f. So we write the expression for that function, which would be x plus 2. And now step 2, replace each x with the expression of the inner function. So we don't have f of x, we have f of g of x, which means we write the f function, and instead of writing x, we replace each x with the function g, which would be x squared. So we substitute x squared in for x here. So this shows us that f of g of x is equal to x squared plus 2. Now let's say we wanted to evaluate this composition of functions with an actual numerical value. Let's say we had f of g of negative 3. We first want to evaluate the inner function. So g of negative 3 is equal to negative 3 squared, and that's equal to 9. So g of negative 3 is equal to 9. So we want to replace the inner function with the value from step 1, which is 9. So we get f of g of negative 3 is equal to f of 9, since g of negative 3 is equivalent to 9. And now the third step, we can evaluate the outer function f for f of 9. So we have the f function here, x plus 2. So if we substitute 9 for x, we get 9 plus 2, which is equal to 11. So we see f of g of negative 3 is equal to 11. So that is how you would go about evaluating the composition of functions, whether you are substituting an expression or a number. Let's now have you try a few practice questions. F of x is equal to 2x squared plus x, and g of x is equal to x minus 1. Question number 1, what is g of f of x? Question number 2, what is f of g of negative 2? And question number 3, what is g of f of 3? Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, write the expression for the outer function. So we were asked to find g of f of x. So the outer function would be g of x, which would be x minus 1. And now step 2, replace each x with the expression of the inner function, which would be f. So we replace this x with 2x squared plus x. And when we do so, we see that g of f of x is equal to 2x squared plus x minus 1. So that is the answer to question number 1. Let's now have a look at question number 2. We're asked to find f of g of negative 2. So step 1, evaluate the inner function, g of negative 2. So we go to g, which is x minus 1, and we substitute negative 2 in for x. And now we have negative 2 minus 1, which is negative 3. So step 2, replace the inner function, g of negative 2, with the value from step 1, which is negative 3, showing us that f of g of negative 2 is equal to f of negative 3. And now we can evaluate the outer function f for negative 3, giving us negative 3 plugged in for x here and here in the f function, which would be 2 times negative 3 squared minus 3. Negative 3 squared is 9. 2 times 9 would give us 18. And 18 minus 3 is equal to 15. So we see the answer to question number 2 is f of g of negative 2 is equal to 15. And that is the answer to question number 2. Let's now have a look at question number 3. We're asked to find g of f of 3. So step 1, evaluate the inner function, which would be f of 3. So we plug in 3 for x here and evaluate, giving us 2 times 3 squared, which is 9. 9 times 2 is 18. And 18 plus 3 is equal to 21. So we have f of 3 is equal to 21. So the second step is to replace the inner function, f of 3, with the value from step 1, which is 21, giving us g of 21. And now we can evaluate the outer function g here for 21. So we plug in 21 for x in the g function, giving us 21 minus 1, which would give us 20. So we see that g of f of 3 is equal to 20. And that is how you go about evaluating the composition of functions. Let's now discuss how we go about combining functions by using the basic operations. So let's begin by discussing how we go about adding functions together. The sum of two functions, f and g, is defined as f plus g of x is equal to f of x plus g of x. So when we want to add two functions together, we need to write out the first function, then write out the second function, and then we'll add together the like terms between those two functions. We'll take a look at an example together, but before we do so, let's quickly review a concept regarding exponents. To add two terms together, both terms must have the same variable with the same exponent. Terms with the same variable but different exponents cannot be added together. So for example, 3x plus 5x can be added together since the exponent for both x's is 1. So we can combine 3 and 5 to give us 8x. But for this example, x has an exponent of 2, and this x term has an exponent of 1. So these two terms cannot be combined together. So keep this in mind, as this is very important when we are adding functions together. So let's walk through this example together. Our first function is f of x is equal to 2x minus 1. The second function is g of x is equal to negative x squared plus x. And we're going to take a look at an example of adding the functions together, dealing with just the expressions. And then we'll take a look at adding the functions together for the value of negative 5 in place of x. So let's first look at adding functions together using expressions. So the first thing we want to do is write the expression for each function. So f plus g of x is equal to f of x plus g of x. So you want to write out the f function, and then you want to write out the g function. That gives us 2x minus 1 minus x squared plus x. And now step 2, combine the like terms. So we have negative x squared plus 2x plus x. This x term and this x term can be combined together to give us 3x, giving us the final result. F plus g of x is equal to negative x squared plus 3x minus 1. So when we add functions together using expressions, the final answer will be an expression that still contains the variables from those expressions. Now let's take a look at adding functions using numbers. Step 1 remains the same, write the expression for each function. So we do so, giving us 2x minus 1 minus x squared plus x. But now step 2, we want to replace each x with negative 5. So we want to replace this x with negative 5, this x with negative 5, and this x with negative 5. And once we do so, we get f plus g of negative 5 is equal to 2 times negative 5 minus 1 minus negative 5 squared minus 5. And the last step, we evaluate the expression, giving us 2 times negative 5, which is negative 10, minus 1 minus 25 minus 5. Negative 10 minus 1 is negative 11, minus 25 is negative 36, minus 5 is negative 41. So we get f plus g of negative 5 is equal to negative 41. So when we're adding functions using expressions, the final answer will be an expression with the variables. And when you're adding functions using numbers, the final answer will be a number. So that is how you go about adding functions. Let's now have you try a few practice questions. F of x is equal to negative 3x plus 2. G of x is equal to x squared minus x. And h of x is equal to 4x. Question number 1. F plus g of x is equal to what? Question number 2. F plus h of x is equal to what? Question number 3. f plus g of 6 is equal to what? In question number 4, g plus h of negative 2 is equal to what? Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, write the expression for each function. So we have f plus g of x is equal to f of x plus g of x. So we want to write out the f function and the g function, giving us negative 3x plus 2 plus x squared minus x. And now step 2, combine the like terms. So we can combine negative x and negative 3x to give us negative 4x, giving us x squared minus 4x plus 2 as our final answer. So this would be the answer to question number 1. F plus g of x is equal to x squared minus 4x plus 2. Let's now have a look at question number 2. We're asked to find the sum of f plus h of x. So we want to write out the f function and then write out the h function. And that would give us negative 3x plus 2 plus 4x. And now we can combine the like terms, 4x and negative 3x, to give us x. So the answer to question number 2 is f plus h of x is equal to x plus 2. Let's now have a look at question number 3. We're asked to find f plus g of 6. So we want to combine f of 6 plus g of 6. So step 1, write out the expression for each function, f and g. That gives us negative 3x plus 2 plus x squared minus x. And now we want to replace each x with 6. And once we do that, we get negative 3 times 6 plus 2 plus 6 squared minus 6. And now we want to evaluate the expression. That would give us negative 3 times 6, which is negative 18, plus 2 plus 6 squared, which is 36, minus 6. And negative 18 plus 2 is negative 16, plus 36 would be positive 20, minus 6 would be positive 14. So the answer to question number 3 is f plus g of 6 is equal to 14. In question number 4, we're asked to find g plus h of negative 2. So that would give us g of negative 2 plus h of negative 2. So step 1, write the expression for each function. So that would give us x squared minus x plus 4x. And now step 2, replace each x with negative 2, giving us negative 2 squared minus negative 2 plus 4 times negative 2. And now we can evaluate the expression, which would be negative 2 squared, which is 4, minus negative 2 is plus 2, plus 4 times negative 2 would be negative 8. 4 plus 2 is 6. 6 minus 8 is negative 2. So the answer to question number 4 is g plus h of negative 2 is equal to negative 2. And that is how you would go about adding functions together. Let's now discuss how we go about subtracting functions. The difference of two functions, f and g, is defined as f minus g of x is equal to f of x minus g of x. So this is similar to adding functions together. You want to write out the expression for each function, but instead of a positive sign or addition between them, we have a negative sign. Now, as far as exponents are concerned, to subtract one term from another term, both terms must have the same variable with the same exponent. Terms with the same variable but different exponents cannot be subtracted. So for example, 3x minus 5x is equal to negative 2x, because both of these x's have the same exponent, which is 1. So the final term will have an exponent of 1 as well. But if the initial x terms had different exponents, such as this example, 3x squared minus 5x, x squared cannot subtract x, so this cannot be simplified any further. So just like addition, subtraction works the same way. The exponents need to be the same in order to combine the terms. So let's take a look at an example together. F of x is equal to 2x minus 1, and g of x is equal to negative x squared plus x. Question number 1, what is f minus g of x equal to? And question number 2, what is f minus g of negative 5 equal to? So we'll take a look at subtracting exponents using an expression, and then we'll take a look at subtracting exponents using numbers. So first we were asked to find f minus g of x, and that's equal to f of x minus g of x. So step 1, write the expression for each function, f and g. That would be 2x minus 1 minus negative x squared plus x. And now, step 2, distribute the negative 1 here to each term in the second function. So that would give us 2x minus 1. And we have negative 1 times negative x squared, which is positive x squared. And negative 1 times x will give us negative x. So now we have 2x minus 1 plus x squared minus x. So the third step is to combine the like terms. Negative x plus 2x would give us just x. So the final answer will be x squared plus x minus 1. So f minus g of x is equal to x squared plus x minus 1. So that is how you subtract functions using expressions. Let's have a look at the example f minus g of negative 5. This will be equal to f of negative 5 minus g of negative 5. So step 1 is to write the expression for each function, f and g. So again, we get 2x minus 1 minus negative x squared plus x. Step 2 is the same. Distribute the negative 1 to each term in the second function, giving us 2x minus 1 minus negative x squared, which is plus x squared. And negative 1 times x is negative x. And now that we've written out the expression and distributed the negative 1, the third step is to replace each x with negative 5. When we do so, we get 2 times negative 5 minus 1 plus negative 5 squared minus negative 5. And now we can evaluate the expression, which would be 2 times negative 5, which is negative 10, minus 1, plus negative 5 squared is plus 25, minus negative 5 is plus 5, and negative 10 minus 1 is negative 11, plus 25 is positive 14, plus 5 would give us 19. So we get f minus g of negative 5 is equal to 19. So that is how we go about subtracting functions using expressions and numbers. Let's now have you complete a few practice questions. F of x is equal to negative 3x plus 2. G of x is equal to x squared minus x. And h of x is equal to 4x. Question number 1. What is f minus g of x equal to? Question number 2. What is f minus h of x equal to? Question number 3. What is f minus g of 6 equal to? And question number 4. What is g minus h of negative 2 equal to? Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, write the expression for each function. So we know f minus g of x is equal to f of x minus g of x. So we want to write out the f function and the g function. So that gives us negative 3x plus 2 minus x squared minus x. And now step 2, distribute the negative 1 to each term in the second function. That would give us negative 3x plus 2 minus x squared plus x. Negative 1 times negative x would give us plus x. And now that we've distributed the negative 1, we can combine the like terms, positive x and negative 3x, to give us negative 2x. So the final answer to question number 1 is f minus g of x is equal to negative x squared minus 2x plus 2. And that is the answer to question number 1. Let's now have a look at question number 2. We were asked to find f minus h of x. So we'll have f of x minus h of x. So step 1, write the expression for each function, f and h. That would be negative 3x plus 2 minus 4x. And now step 3, combine the like terms. Negative 3x minus 4x would give us negative 7x. So the answer to question number 2 is f minus h of x is equal to negative 7x plus 2. So that is the answer to question number 2. Let's now have a look at question number 3. We were asked to find f minus g of 6. So that'll be equal to f of 6 minus g of 6. So step 1, write the expression for each function, f and g. That would be negative 3x plus 2 minus x squared minus x. Step 2, distribute the negative 1 to each term in the second function. Negative 1 times x squared will give us negative x squared. And negative 1 times negative x will give us positive x. And now step 3, what we want to do is replace each x with 6. So we replace this x with 6, this x with 6, and this x with 6. Giving us negative 3 times 6 plus 2 minus 6 squared plus 6. And now we can evaluate the expression here. Giving us negative 3 times 6, which is negative 18, plus 2 minus 36 plus 6. And negative 18 plus 2 is negative 16. Minus 36 is negative 52. Plus 6 is negative 46. So we get f minus g of 6 is equal to negative 46. And that is the answer to question number 3. Let's now have a look at question number 4. We were asked to find g minus h of negative 2. And that'll be equal to g of negative 2 minus h of negative 2. So we first want to write the expression for each function, g and h, which would be x squared minus x minus 4x, which would just be minus 4x. And now step 3, replace each x with negative 2, giving us negative 2 squared minus negative 2 minus 4 times negative 2. And now we can evaluate the expression here, which would be negative 2 squared, which is 4, minus negative 2 is plus 2, minus 4 times negative 2 is positive 8. 4 plus 2 is 6, plus 8 would give us 14. So we find that g minus h of negative 2 is equal to 14. So that is the answer to question number 4. And that is how we go about subtracting functions. Let's now have a look at how we go about multiplying functions. The product of two functions, f and g, is defined as f times g of x is equal to f of x times g of x. So just like addition and subtraction, when we are multiplying two functions, it is the same as taking the first function and multiplying it times the second function. Now, when we are multiplying functions, you want to remember the following. Add the exponents together when multiplying two terms with the same variable. So let's say we had 2x times 3x squared. For addition and subtraction, the x's would need to have the same exponent, but for multiplying that is not the case. So here, this x has an exponent of 1, and in this term, this x has an exponent of 2. So when we multiply them, we add together the exponents for the x, which would be 1 plus 2 would give us 3. We multiply the coefficients the way we normally would. 2 times 3 gives us 6. So we see 2x times 3x squared is 6x cubed. Another example, if we had negative 4x to the third times 5x to the fifth, we multiply the coefficients. Negative 4 times 5 gives us negative 20. And x to the third times x to the fifth is equal to x to the 3 plus 5, which would be 8. So when we're multiplying functions, remember you multiply the coefficients. And when you're multiplying like terms, you add the exponents together. Let's walk through an example together. Given f of x is equal to 2x minus 1, and g of x is equal to negative x squared plus x. Question number 1, f times g of x is equal to what? In question number 2, f times g of negative 5 is equal to what? So let's walk through multiplying functions using expressions, and then we'll take a look at multiplying functions using numbers. So first, we want to write the expression for each function. So we want to write out the f function and we want to write out the g function, which would be 2x minus 1 times negative x squared plus x. Since we're multiplying, we keep both these expressions in a set of parentheses. And step 2, multiply each term in the first function times each term in the second function. This is the FOIL method. So we'll do 2x times negative x squared will give us negative 2x to the third. The exponent 1 plus the exponent 2 would give us 3. 2 times negative 1 is negative 2. And now we multiply this term times the second term in the second function, which gives us 2x times x, which is 2x squared. And now, since we've multiplied both terms in the second function by this term, we now want to multiply the second term in the first function times both terms in the second function, giving us negative 1 times negative x squared, which would be positive x squared. And then negative 1 times x gives us negative x. So we get negative 2x cubed plus 2x squared plus x squared minus x. And now the third step is to combine the like terms, 2x squared plus x squared, which would give us 3x squared. So the final answer is f times g of x is equal to negative 2x cubed plus 3x squared minus x. So that is how we go about multiplying functions using expressions. Let's now walk through an example using numbers for x. Step 1, write the expression for each function. So we write out the f function, 2x minus 1, inside a pair of parentheses. And we write out negative x squared plus x, the g function, inside a pair of parentheses. And now we want to replace each x with negative 5. So that'll give us 2 times negative 5 minus 1 times negative 5 squared minus 5. And now that we've replaced each x with negative 5, we can evaluate this expression. So we get 2 times negative 5, which is negative 10 minus 1, times negative 5 squared is 25. So that would give us negative 25 minus 5. Negative 10 minus 1 is negative 11, times negative 25 minus 5, which is negative 30. And negative 11 times negative 30 is equal to positive 330. So f times g of negative 5 is equal to 330. And that is how you would go about multiplying fractions using expressions and numbers. Let's now have you try a few practice questions. If f of x is equal to negative 3x plus 2, and g of x is equal to x squared minus x, and h of x is equal to 4x, Question number 1. What is f times g of x equal to? Question number 2. What is f times h of x equal to? Question number 3. What is f times g of 6 equal to? And question number 4. What is g times h of negative 2 equal to? Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, write the expression for each function. So we'll write out the f function, negative 3x plus 2, and we'll multiply that times the g function, which is x squared minus x. And now step 2, multiply each term in the first function times each term in the second function, aka use the FOIL method to expand this expression. When we do so, we get negative 3x times x squared, which is negative 3x cubed. And negative 3x times negative x is positive 3x squared. And now we move to the second term in the first function. 2 times x squared is 2x squared. And then 2 times negative x is negative 2x. And now, step 3, we want to combine the like terms, positive 3x squared and positive 2x squared, to give us positive 5x squared. So the final answer to question number 1 is f times g of x is equal to negative 3x cubed plus 5x squared minus 2x. Let's now have a look at question number 2. We are asked to evaluate f times h of x. So that'll be f of x times h of x. So we want to write the expression for the f function and the h function inside a pair of parentheses. And now step 2, multiply each term in the first function times each term in the second function. So that would give us negative 3x times 4x, which is negative 12x squared. And then we multiply 2 times 4x to give us 8x. So the final answer to question number 2 is f times h of x is equal to negative 12x squared plus 8x. So that is the answer to question number 2. Let's now have a look at question number 3. We're asked to find f times g of 6. So step 1, write the expression for each function, both f and g, and we'll put them inside a pair of parentheses. And now step 2, replace each x with 6. So when we do so, we get negative 3 times 6 plus 2 times 6 squared minus 6. And now we can evaluate the expression, which would be negative 3 times 6, which is negative 18, plus 2 times 6 squared, which is 36, minus 6. Negative 18 plus 2 is negative 16, times 36 minus 6, which is 30. And negative 16 times 30 is equal to negative 640. So the answer to question number 3 is f times g of 6 is equal to negative 640. Let's now have a look at question number 4. We were asked to evaluate g times h of negative 2. So we want to write out the g function and the h function inside a pair of parentheses. And now step 2, replace each x with negative 2. So when we do so, we get negative 2 squared, which is 4, minus negative 2 is plus 2, times 4 times negative 2, which is negative 8. 4 plus 2 is equal to 6. And 6 times negative 8 is negative 48. So we see question number 4, g times h of negative 2 is equal to negative 48. So that is how we go about multiplying functions using both expressions and numbers. Let's now discuss how we go about dividing functions. The quotient of two functions, f and g, is defined as f divided by g of x is equal to f of x divided by g of x. Now, when we are dividing functions, we need to pay close attention to both the exponents and the denominator. For the exponents, to divide two terms, subtract the exponent in the denominator from the exponent in the numerator. So we divide our coefficients the way we normally divide numbers. Negative 20 divided by 4 is equal to negative 5. For the variables, we have x to the third divided by x to a power of 1. So the quotient is x to the 3 minus 1, which would be 2. So divide numbers the way you normally would. For variables, you subtract the exponent in the denominator from the exponent in the numerator. Now, another thing to keep in mind when we are dealing with dividing functions, if the denominator has two or more terms, then do not divide the term or terms in the numerator by the terms in the denominator by subtracting the exponents. That only applies when you have a singular term in the denominator. So for an example like this one, negative 20x squared plus 17 divided by x squared plus 2x minus 1. Since we are not dividing each term by all the terms in the denominator, the way we would if we had a singular term in the denominator, we are going to leave this expression as is. Okay, so in this chapter, you're only going to simplify the expression further if there is a singular term in the denominator. So let's walk through an example together. Given f of x is equal to 2x minus 1, and g of x is equal to negative x squared plus x. Question number 1, what is f divided by g of x equal to? And question number 2, what is f divided by g of negative 5 equal to? So we'll take a look at how to divide functions using expressions, and then we'll take a look at how to divide functions using a number. So beginning with f divided by g of x, step 1, write the f function in the numerator. Since f divided by g of x is equal to the f function divided by the g function, we want to write the f function in the numerator. And then step 2, write the g function in the denominator. And since we have two terms in the denominator, we'll stop here. So we see f divided by g of x is equal to 2x minus 1 divided by negative x squared plus x. So when dividing functions, the first function listed will be our numerator. The second function will be our denominator. So let's take a look at how to divide functions using numbers. Step 1, write the f function in the numerator. And step 2, write the g function in the denominator. So again, we wind up with 2x minus 1 divided by negative x squared plus x. But now we're going to replace x with negative 5. So we'll replace this x with negative 5, this x with negative 5, and this x with negative 5. And now we can evaluate the expression to find our answer, giving us 2 times negative 5, which is negative 10 minus 1 in the numerator. Negative 5 squared is 25, so we get negative 25 minus 5 in the denominator. Negative 10 minus 1 is negative 11, divided by negative 25 minus 5, which is negative 30. The negatives cancel each other out, leaving us with 11 over 30 as our answer. So we see f divided by g of negative 5 is equal to 11/30. So that is how you go about dividing functions using both expressions and numbers. Let's now have you try a few practice questions. Given f of x is equal to negative 3x plus 2, g of x is equal to x squared minus x, and h of x is equal to 4x. Question number 1, what is f divided by g of x equal to? Question number 2, what is f divided by h of x equal to? Question number 3. What is f divided by g of 6 equal to? And question number 4. What is g divided by h of negative 2 equal to? Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. Step 1, write the f function in the numerator. And step 2, write the g function in the denominator. So our f function is negative 3x plus 2. And our g function is x squared minus x. And since we have two terms in the denominator, we'll stop here. So f divided by g of x is equal to negative 3x plus 2 divided by x squared minus x. So that is the answer to question number 1. Let's now have a look at question number 2. What is f divided by h of x equal to? So step 1, write the f function in the numerator. And step 2, write the h function in the denominator. And now step 3, we can divide each term in the numerator by the term in the denominator, giving us negative 3x divided by 4x. The x's cancel each other out, giving us negative 3 over 4. And then we have plus 2 over 4x. 2 over 4 simplifies to 1 over 2x. So we get f divided by h of x is equal to negative 3/4 plus 1 over 2x. And that is the answer to question number 2. Let's now have a look at question number 3. We're asked to find f divided by g of 6. So that would be equal to f of 6 divided by g of 6. So step 1, write the f function in the numerator. And step 2, write the g function in the denominator, giving us negative 3x plus 2 divided by x squared minus x. And now step 3, replace each x with 6. So when we do so, we get negative 3 times 6 plus 2 divided by 6 squared minus 6. And now we can evaluate the expression, which should be negative 3 times 6, which is negative 18 plus 2, over 6 squared, which is 36, minus 6. Negative 18 plus 2 is negative 16, over 36 minus 6, which is 30. So we get negative 16 over 30, which can be simplified to negative 8 over 15. So the answer to question number 3 is f divided by g of 6 is equal to negative 8/15. And that is the answer to question number 3. Let's now have a look at question number 4. We're asked to find g divided by h of negative 2. And this would be equal to g of negative 2 divided by h of negative 2. So step 1, write the g function in the numerator. And then step 2, write the h function in the denominator. So that would give us x squared minus x divided by 4x. And now step 3, replace each x with negative 2. So that would give us negative 2 squared minus negative 2 over 4 times negative 2. And now we can evaluate the expression, giving us negative 2 squared, which is 4, minus negative 2 is plus 2, divided by 4 times negative 2, which is negative 8. 4 plus 2 is equal to 6. So we get 6 over negative 8, which is equivalent to negative 3/4, or negative 0.75. So the answer to question number 4 is g divided by h of negative 2 is equal to negative 0.75. And that is how we go about dividing functions. Let's now move on to the next section of the chapter, in which we will discuss graphing functions. Now, the graph of a function can be sketched by using a few points from a table of values. The first column contains the input values, and the second column contains the output values. So the first column is our x's. We plug these values into x, and the number in the second column beside it is the result of plugging in that number. Now the best way to review graphing functions is to go through an example together, so let's do so. You'll be asked to sketch a function such as f of x is equal to x squared. So what do we want to do here? We want to plug in a few values for x so that we can get a few of the resulting y values, and then use these points to sketch our graph. So step 1, evaluate f of x with 5 different input values. I'm going to use -2, -1, 0, +1, and +2 for our x's. This way we can sketch the points closest to the origin. So when we plug in -2 for x, we get -2 squared, which gives us 4. So the input is -2 and the output is +4. So that is row 1 in our table of values. We then plug in -1 for x, giving us -1 squared, which is equal to +1. So -1 is our input and +1 is the output. We then want to plug in 0 for x, showing us f of 0 is equal to 0 squared, which is equal to 0. So in our table, 0 is the input and 0 is the output in the third row. Now we plug in +1 for x, showing us f of 1 is equal to 1 squared, which is equal to +1. So the fourth row of this table, we have 1 as the input and 1 as the output. And for the fifth point, we'll plug in +2 for x, giving us 2 squared, which is equal to +4, showing us the input is +2 and the output is +4. So now we have 5 ordered pairs from this function, nicely laid out in a table for us. And now step 3, we want to plot the points from the table of values on a coordinate plane, and then we will draw a line through those points. So we have an xy coordinate plane. We want to plot -2, +4. And then we plot -1, +1. We then plot 0, 0 at the origin. Our fourth point is +1, +1. And our fifth point is +2, +4. And since we know we had a quadratic, x squared, we know the line we are drawing is going to be slightly curved through these points. So this would be the sketch of f of x is equal to x squared. So to sketch a function, you want to use the function to plug in numerous values for x and then record the resulting y's and keep track of these ordered pairs in a table of values, and then use the table of values to plot the points on a coordinate plane and then draw a line through those points. So that is how we go about sketching a function. Let's have you try a few practice questions. Question number 1, sketch f of x is equal to -3x plus 1. Question number 2, sketch g of x is equal to -x squared plus 3. Question number 3, sketch h of x is equal to 2x squared minus 1. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, evaluate f of x with 5 different input values. So we were given f of x is equal to -3x plus 1. So we are going to plug in -2, -1, 0, 1, and 2 for our x's and record the resulting y's. So f of -2 is equal to -3 times -2, which is 6, plus 1 would give us 7. So we want to record the input -2 and the output value +7 in a table of values here. So we have -2, 7. And now we plug in -1 for x, showing us f of negative 1 is equal to negative 3 times negative 1, which is 3, plus 1 would give us positive 4. So the input is negative 1 and the output is 4. We now plug in 0 for x, showing us f of 0 is equal to negative 3 times 0, which is 0, plus 1 would give us 1. So the input value is 0 and the output value is positive 1. We now plug in positive 1 for x, showing us f of 1 is equal to negative 3 times 1, which is negative 3, plus 1 would be negative 2. So the input is positive 1 and the output is negative 2. And for the fifth point, we plug in positive 2 for x, showing us f of 2 is equal to negative 3 times 2, which is negative 6, plus 1 would give us negative 5. So the input is positive 2, the output is negative 5. And now we have 5 points that we can use to sketch our function. So step 3, plot the points from the table of values on a coordinate plane. And step 4, draw a line through the points. So our first point is negative 2, positive 7. Plot the point. The next point is negative 1, positive 4. Plot that point. The third point is 0, 1. Plot that point. The fourth point is 1, negative 2. And the fifth point is 2, negative 5. So now that we've plotted the points, we can draw a line through these points to show us the sketch of f of x. So this would be the answer to question number 1. Let's now have a look at question number 2. We were given g of x is equal to negative x squared plus 3. So step 1, evaluate g of x with 5 different input values. And then step 2, record the input and output values from step 1 in a table of values. When we do this, we get g of negative 2 is equal to negative 1 times negative 2 squared, which would be negative 4. Negative 4 plus 3 is equal to negative 1. So our input value is negative 2 and our output value is negative 1. We then plug in negative 1 for x, showing us g of negative 1 is equal to negative 1 times negative 1 squared, which would be negative 1. And negative 1 plus 3 is equal to positive 2. So the input is negative 1 and the output is positive 2. We now plug in 0 for x, showing us g of 0 is equal to negative 0 squared plus 3. This would be 0 plus 3, which is equal to 3. So the input is 0 and the output is 3. We then plug in 1 for x, showing us g of 1 is equal to negative 1 squared, which is negative 1. Plus 3 would be positive 2. So the input is 1, the output is positive 2. G of 2 is equal to negative 2 squared, which would be negative 4. Plus 3 would be negative 1. So our input is 2 and the output is negative 1. And now that we have the 5 points that we are going to use to sketch the function g of x, the third step is to plot these points on a coordinate plane and then draw a line through them. So the first point is negative 2, negative 1. The second point is negative 1, positive 2. The third point is 0, 3. The fourth point is 1, 2. And the fifth point is 2, negative 1. And now we have the 5 points that we can use to sketch g of x. So we draw a curved line through these since we know it's quadratic. And we wind up with this sketch for a g of x. So that is the answer to question number 2. Let's now have a look at question number 3. We were given h of x is equal to 2x squared minus 1. So step 1, evaluate h of x with 5 different input values. And then step 2, record the input and output values from step 1 in a table of values. So we'll plug in -2 first, showing us h of -2 is equal to 2 times -2 squared minus 1. -2 squared would be 4. 2 times 4 is 8, giving us 8 minus 1, which is equal to 7. So the input is -2 and the output is positive 7. We then plug in -1 for x, showing us h of -1 is equal to 2 times -1 squared minus 1. -1 squared would be 1. 2 times 1 is 2. And 2 minus 1 is equal to positive 1. So the input is -1 and the output is positive 1. We then plug in 0 for x, giving us h of 0 is equal to 2 times 0 squared, which would be 0, minus 1 would give us -1. So the input is 0 and the output is -1. The next point is 1. H of 1 is equal to 2 times 1 squared minus 1. 1 squared is 1. 2 times 1 is 2. And 2 minus 1 is equal to 1. So the input is 1 and the output is 1. And for the fifth point, we plug in 2 for x, showing us h of 2 is equal to 2 times 2 squared minus 1. 2 squared is 4. 2 times 4 is 8. 8 minus 1 is equal to 7. So the input is 2 and the output is 7. So now that we have the 5 points we are going to use to sketch h of x, the third step is to plot the points from the table of values on a coordinate plane. And then step 4 is to draw a line through the points. The first point is -2, positive 7. The second point is -1, positive 1. The third point is 0, -1. The fourth point is 1, 1. And the fifth point is 2, 7. And with this, we have the 5 points we can use to sketch h of x. So this would be the sketch for h of x is equal to 2x squared minus 1. So that is how you go about sketching a function. Let's now discuss how we would go about sketching piecewise functions. Now, a piecewise function is a function that has different equations that represent specific intervals of the x values. So here we see that this function has a value of 6 from -infinity leading up to -2. And from -2 to +2, it has a different expression representing the function. And from +2 to +infinity, it has a third expression representing the function. Now what this means for sketching a piecewise function is graphing piecewise functions requires creating a table of values for each interval of the x values. So starting with the first interval, we'll need to plot points from -infinity up to -2. So we'll use 3 points for this part of the interval. Between -2 and +2, we'll use 3 or 4 points to help sketch this portion. And then lastly, we'll use 3 points to sketch the third part of this function, x plus 5. Now, something to keep in mind, you'll see here at the end of each interval, you either have a filled in circle or an empty circle. This is because of the fact that the expression that includes or equal to includes the value at the limit, while the expression without it does not. So here we see that x is less than or equal to -2. So since x can equal -2, the first interval has a circle that's filled in, but the second interval is empty since this is x is greater than -2, but it is not equal to -2. Only one of them can have this equal sign. The function can't be equal to both, or else it would have two y values affiliated with that one x, and then it would not be a function. Same thing with this part of our function at +2. Here we have x is less than or equal to 2. So the second interval has the circle that's filled in, since when x is equal to 2, it is a part of the second interval, not the third interval. The third interval is x is greater than 2, so it is every point after 2, but not 2 itself. Okay, so pay very close attention to the or equal to sign, as it will affect your resulting graph. So let's walk through an example together. Let's say you're asked to sketch f of x is equal to 6 if x is less than or equal to -2. F of x is equal to x squared if -2 is less than x, which is less than or equal to +2. And f of x is equal to x plus 5 if x is greater than 2. So this is the piecewise function we just saw, but now we will sketch it from scratch. So how do we do so? Step 1, evaluate the first interval of f of x with 3 different values. So this will be pretty simple since the function has a consistent value of 6. So since we're leading up to the point of -2, we can use -2, -3, and -4. We're getting more negative. And for each corresponding y value, it is 6 for each one. Since no matter what, when x is less than or equal to -2, the function will be equal to 6. So each output will be 6. And now step 3, evaluate the second interval of f of x with 3 different values. So we have x squared if -2 is less than x, which is less than or equal to 2. So I always like to use the limits so we can see what is happening at the limits. So we plug in -2 for x, we get f of -2 is equal to -2 squared, which shows us that f of -2 is equal to 4. We can then go to the middle. 0 would be halfway between -2 and +2. So when we plug in 0 for x, we get f of 0 is equal to 0 squared, which is 0. So the input is 0 and the output is 0. And then we want to plug in +2 for x, showing us f of 2 is equal to 2 squared, which is 4. So the input is 2 and the output is 4. So this is the second table of values that we use for the second interval. And we need a third table of values for the third interval, x plus 5. So we want to evaluate the third interval of f of x with 3 different values, and then record the input and output values from step 5 in a table of values. When we do so, we'll plug in 2, which is at the limit. F of 2 is equal to 2 plus 5, which shows us f of 2 is equal to 7. Now, although this particular point is not included in the third interval, this helps us understand where we should be placing the empty circle for this interval. So that is why I use 2 here, even though 2 is not included in this specific interval. It's so we know where to put the circle. The next point we'll plug in is 3 for x, showing us f of 3 is equal to 3 plus 5, which is 8. So our input is 3 and our output is 8. And the third point, we'll plug in 4 for x, showing us f of 4 is equal to 4 plus 5, which is 9. So the input is 4 and the output is 9. So now that we have the table of values for each interval of this function, step 7 is to plot the points for each interval of the function on a coordinate plane. So we'll start with our first table of values. In the first interval, it has a consistent value of 6 when x was equal to or less than -2. So our first 3 points are -4, +6, -3, +6, and -2 and +6. And then we draw a line through the points. So this will be our first interval here. And now we take a look at the second table of values. The first point is -2, +4. The second point is 0, 0. And the third point is 2, positive 4. And now that we've plotted the points, we can draw a line through those points. And now for the third interval, the first point is 2, 7. The second point is 3, 8. And the third point is 4, 9. And now with these 3 points, we can draw a line through the points to give us a sketch of that interval as well. And now that we have a sketch for all 3 intervals of this piecewise function, we want to take a look at the less than and greater than signs in the piecewise function to help us determine what types of circles we should add to the ends of each interval. So step 9, place a filled circle at the end of the first interval where x is equal to negative 2. This is because here it is x is less than or equal to negative 2. So at negative 2 along the x-axis, it is the first interval that has a filled circle. So since this one is filled, that means for step 10, we want to place an empty circle at the end of the second interval where x is equal to negative 2. So at negative 2, the function has a value of 6 here, and it does not have a value for the second interval at exactly negative 2, but it does for each point after that. And now at the other end of the second interval, we want to place a filled circle where x is equal to positive 2. Here in the second interval, we have x is less than or equal to. Since it can be equal to 2, at 2, the circle is filled, which means for the next circle, where x is equal to 2 for the third interval, we're going to place an empty circle since x is greater than but not equal to 2. And once we have that, we have now completed the sketch for the piecewise function. So that is how we go about graphing a piecewise function. Let's now have you complete a practice question. Sketch f of x is equal to x minus 2 if x is less than or equal to negative 3. F of x is equal to x squared plus 3 if negative 3 is less than x, which is less than 3. And f of x is equal to negative 4 if x is greater than or equal to positive 3. Pause the video, answer this question, and then press play when you are ready to begin. Step 1. Evaluate the first interval of f of x with 3 different values. So we have f of x is equal to x minus 2 if x is less than or equal to negative 3. So we'll start where x is equal to negative 3, and then we'll proceed to points that are smaller than negative 3. So we'll use negative 3, negative 4, and negative 5 in the first table of values. So when we evaluate f of negative 3, we want to plug in negative 3 for x here. So we get f of negative 3 is equal to negative 3 minus 2, which is equal to negative 5. So the first row in this table of values is x is negative 3 and y is negative 5. We then want to evaluate f of negative 4, which would be equal to negative 4 minus 2, which is equal to negative 6. So the entry would be negative 4, negative 6. And then the third row would be f of negative 5, which is equal to negative 5 minus 2, which is equal to negative 7. So the input value would be negative 5 and the output value would be negative 7. And now that we have 3 points from this interval of the piecewise function, we can now work on the second table of values by evaluating the second interval of f of x with 3 different values. And then we will record the input and output values in a table of values. So when we evaluate f of negative 3, f of negative 3 is equal to negative 3 squared, which is 9, plus 3. which is equal to 12. So our input is -3 and our output is 12. We can then plug in 0 for x. F of 0 is equal to 0 squared, which is 0, plus 3 would be 3. So the input is 0 and the output is 3. And then for f of 3, we get f of 3 is equal to 3 squared, which is 9, plus 3 would be 12. So the input value is 3 and the output value is 12. And now that we have 3 points for the second interval, we can now work on the third interval. So step 5, evaluate the third interval of f of x with 3 different values. And then step 6, record the input and output values in a table of values. For this one, the interval always has a value of -4 if x is greater than or equal to 3. So when x is 3, 4, 5, or any larger number, the value of the function, or the y value, is consistently -4. So this is the table of values for our third interval. And now that we have the 3 table of values, step 7 is to plot the points for each interval of the function on a coordinate plane. So starting with the first table of values, our first point is -3, -5. Our second point is -4, -6. And our third point is -5, -7. And now that we have 3 points that we can use, we can sketch this section of the function by drawing a line through these points. And this would continue for x is -infinity. And also y, it would head towards -infinity for y. And now we can begin sketching the second interval. The first point was -3, 12. The second point was 0, 3. And the third point was 3, 12. And with these 3 points, we can now sketch the second section of the function by drawing a line through those points. And now for the third interval, the first point is 3, -4. The second point is 4, -4. And the third point is 5, -4. And now we can sketch the third interval of this piecewise by drawing a line through the points. And now we can complete this sketch by adding these circles to the ends of each interval. So for step 9, we want to place a filled circle at the end of the first interval where x is equal to -3. The circle is filled since in the first interval, x is less than or equal to. So since it can equal -3, we need to fill the circle to indicate that number is included. Step 10, place an empty circle at the end of the second interval where x is equal to -3. It is empty since x is greater than but not equal to -3. So -3 is not included. And now step 11, place an empty circle at the end of the second interval where x is equal to 3. It is empty since x is less than 3 but is not equal to 3, so that number is not included in the second interval. And finally, step 12, place a filled circle at the end of the third interval where x is equal to +3. And it is filled since x is greater than or equal to. So since it can equal 3, that number is included, so the circle is filled. And with that, this would be the answer to question number 1. And that is how we go about sketching piecewise functions. Let's now wrap up the chapter by discussing how we find the domain and range of a particular function. The domain of a function is the set of x values that can be plugged into an equation and yield y values that are real. So let's say we had an xy coordinate plane and we had a line going through it. The x values, or the values along the x-axis for this function, represent the domain. So for what x values does this function exist, essentially? The vertical line test is a method of finding the x values of a curve with no corresponding y values. So let's take this line, for example. we can use a vertical line to try and find any breaks in this line, and there are none. So the domain is the smallest value is negative infinity, because this line continues indefinitely, which means all of these negative real values for x apply. So it will continue to negative infinity in this direction. And then as we proceed in the positive direction of the x-axis, same thing. This function will continue for every value for x in the positive direction. So the domain is negative infinity to positive infinity, and parentheses are always on the side of infinity since it is not an actual number. But let's say we had this function instead. Now when we use a vertical line, we see that once we get to where x is equal to negative 2, there is no y value. And we continue and we see where x is equal to positive 4, there is no y value. So now our domain is a bit different. The first interval of our domain is from negative infinity to negative 2, and that represents all the ordered pairs not shown, all the way up to the portion of the line we see, up to where we get to the gap in the line, this empty circle. So this interval of our function is represented by this right here. And we'll dive deeper into the details of this notation in a minute. You're going to place a u between the intervals. And now this second interval is from negative 2 to positive 4. And notice we have parentheses since negative 2 is not included, since the circle is empty. But this second interval is from negative 2 to 4, represented here. Another u between the intervals. And then the third interval is from positive 4 to positive infinity. And we have parentheses on both sides since 4 is not included, since it is empty. And infinity is not real. It's just indicating this will continue indefinitely. So that is how you would use the vertical line test to find the x values that do not have corresponding y values. And then this will help you write your domain. So let's briefly discuss the range of a function. The range of a function is a set of y values that are possible results of the function. So you will need to pay attention to the y values where there may be a gap in the function. The horizontal line test is a method of finding the y values of a curve with no corresponding x values. So like our original line, for example, if we use a horizontal line, we see that there are no gaps. So the range would be from negative infinity to positive infinity, since this would continue indefinitely, heading all the way down towards negative infinity on the y-axis. And as we continue up, we see that it is going to continue to have y values as we head towards positive infinity. But let's say this were our function. Now when we use the horizontal line, we see there is no x value when y is equal to 1. And as we continue, we see there is no x value when y is equal to 4. So the range would be from negative infinity to positive 1 for the first interval. And we have a parenthesis on the right side of number 1, since 1 is not included, since this is empty. You place a u between the intervals, and now the second interval is from where y is equal to 1 to where y is equal to 4. So we have 1, 4 in the middle. Another u between the intervals, and now the third interval is from y is 4 to positive infinity. So that would be this section here, and it would continue. So let's discuss interval notation a bit further. The set of values from an inequality can be represented by a form known as interval notation. So we have a is less than or equal to x is less than b. And in interval notation form, we would have a bracket, the letter a comma between the entries, and then b would be the second entry here. So there is no x in the interval notation. The smallest value and the largest value of the set are enclosed by either a bracket, if the value is included, So we have less than or equal to. So x can equal a. So we use brackets. So that is why we have a bracket here beside a. Or a parenthesis if the value is not included. So that would be this portion here. We have x is less than b. But since x is not equal to b, we're going to use parentheses in those cases. So that is why here we have b, the larger entry, has a parenthesis to the right of it. Sometimes, as we saw in a previous example, you'll have more than one number that is not included in the domain or function. Two or more intervals may be joined together by a u between each interval. So let's say we had the number line and the domain were all the real numbers except -2 and +2. So this first interval would be from -infinity up to -2. So that's here. We place a u between the intervals. And now the second interval is this middle section here from -2 to +2. They're both empty. So we have parentheses instead of a bracket or brackets. A u between the intervals. And now this third interval here is from +2 to +infinity. So that would be here, the smaller entry on the left, a comma, the larger entry on the right. So this is the layout you would use if you had two numbers missing. It would wind up being 3 unique intervals or sections. Okay, so keep that in mind. Now let's walk through an example together. Let's say this were a sketch of the function f of x. The first question is, what is the domain of f of x? And the second question would be, what is the range of f of x? So let's have a look. So to find the domain using this graph, step 1, use a vertical line to find each x value with no y value. So we'll start at one end of the function and we'll work our way to the other end using a vertical line. Towards the left end, where x is equal to -5, there is no y value. So we'll need to make a note of that. We use the vertical line along the function, and we see that there are no other gaps. But at x is equal to -3, we have a filled-in circle, which lets you know the function ends here. So the domain would be from -5, parenthesis to the left, since -5 is not included. And it would continue to the largest possible value of 3, which is included since it is filled in. So this would be the domain. And now to find the range, we'll focus on the y values of the function. So we will use a horizontal line to find each y value with no x value. We'll start towards the left and work our way to the right again. So where y is equal to -4, there is no x value. So we'll need to make a note of that. And we use the horizontal line and see that all y values are accounted for up until we reach y is equal to +6. So the range would be from -4 to +6, parenthesis on the left side of -4, since the value is not included, and a bracket to the right of 6, since that is included. So that is how you would go about finding the domain and range using a graph. Let's now have you try a few practice questions. Question number 1. What are the domain and range of this function? Question number 2. What are the domain and range of this function? Pause the video. Answer these questions for both questions 1 and 2, and then press play when you are ready to begin. Question 1a, we'll first focus on finding the domain of this function. So step 1, use a vertical line to find each x value with no y value. So we'll start towards the left and make our way to the right. And at the very end of this function, where x is equal to -4, there is no y value. We continue along the curve, and we see all x values are accounted for until we reach x is +4. So the domain would be parenthesis -4, comma, +4, with a bracket to the right. Now we want to find the range. So step 1, use a horizontal line to find each y value with no x value. So we'll start at the bottom and work our way up. And we see that between y is equal to 1 and y is equal to 10, there is at least one x value for each corresponding y value. So the range would be from 1 to 10 and brackets on both sides. Since 1 we have a value, and at 10 we have a value. So those are the answers for question number 1. Let's now have a look at question number 2. So question 2a, we are finding the domain of this graph. So we will start at the left side, and we see where x is equal to -6, there is no y value. We continue with the vertical line, and we see that all y values are accounted for until we reach x is equal to +7. So the domain would be parenthesis -6, that's the smallest x value, up to 7, the largest x value, with parentheses enclosing them, since neither number is included in the function. Now let's take a look at the range. We will use a horizontal line to find each y value with no x value. So we'll start our way at the bottom and work our way up. So the range is from -5, and we see all y values are accounted for, even though -6 has a circle here and 7 has a circle here. We have a value at the origin here. So y values are accounted for between -5 to +3. So we have brackets enclosing -5 and +3. So that is how you would go about finding the domain and range of a function using a graph. Let's now discuss how you would find the domain of a function that has a variable in the denominator. The domain of a function will have restrictions if there is a variable in the denominator, since the denominator cannot equal 0. So when we divide 20 by 4, this is equal to 5. So we can have a positive real number in the denominator and get a real number as a quotient. The number in the denominator can be negative. 20 divided by -4 is equal to -5. So we can divide by a positive number or a negative number, but we cannot divide by 0. This will make the quotient undefined. So in this example, f of x is equal to 5 divided by x minus 4. X cannot equal 4, because if it did, then we would have f of 4 is equal to 5 divided by 4 minus 4, and that would be equal to 0. And then 5 divided by 0 would be undefined. So in your domain, x can equal any number, but it cannot equal 4, because that is the one number that will result in 0. So the domain is all real numbers except 4. Okay, so that's the logic of how we find the domain when a variable is in the denominator. The domain of the function will be all real numbers less than the restricted number, and all of the real numbers greater than the restricted number. So in our case, where x cannot equal 4, it is all the numbers from -infinity up to 4, but not including 4. So the first interval would be from -infinity as the first entry, and +4 as the second entry. Parenthesis to the right, since 4 is not included. A u between the intervals, and then the second interval is from 4 to +infinity. So in the current example, this would be the domain. This is the same as writing all numbers except 4. This is what that would look like in interval notation. If it were a different number, same thing. If it's all real numbers except for 2, the domain would be from negative infinity to 2, and then from 2 to positive infinity. This is the way of saying it's any of these numbers except here. This creates 2 separate intervals. So this would be the general form of when the domain is restricted by just one number. But as we saw earlier in the chapter, the domain may be restricted by several numbers. So if there were a second number, for example, this then creates 3 unique intervals. So the domain would represent that. The first interval, U, the second interval, another U, and then the third interval. So let's walk through an example together. Let's say you're asked to find the domain of f of x, which is equal to 2 divided by 3x plus 6. So we are going to focus on the denominator since this is where the restrictions will come. So step 1, set the denominator equal to 0. So the denominator is 3x plus 6. So we have 3x plus 6 is equal to 0. And now step 2, we want to solve for x. So the first thing we do is subtract 6 from both sides, giving us 3x is equal to 0 minus 6, which is negative 6. And now to remove this coefficient, positive 3, we want to divide both sides by 3, showing us that x is equal to negative 6 divided by 3, which is negative 2. So this shows us the number that x really cannot equal. When x is equal to negative 2, this is when 3x plus 6 is equal to 0. So this is the number we are trying to avoid. So the domain would be from negative infinity to negative 2, parenthesis to the right since negative 2 is not included, a u, and then the second interval would be from negative 2 to positive infinity, parentheses as well, since infinity is not a real number, and negative 2 is not included. So that is how we go about finding the domain when we have a variable in the denominator. Let's now have you complete a few practice questions. Question number 1, find the domain of f of x is equal to 7 divided by x plus 3. Question number 2, find the domain of g of x is equal to 2 divided by x squared minus 4. And question number 3, find the domain of h of x is equal to 2x divided by x squared minus 4x minus 5. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, we had f of x is equal to 7 divided by x plus 3. So step 1, set the denominator equal to 0. And then step 2, solve for x. So we'll do so by subtracting 3 from both sides. So we see that the denominator is equal to 0 when x is equal to negative 3. So the domain is all real numbers except for negative 3. So this would be the domain for f of x. The first interval is from negative infinity to negative 3, parentheses around both, a u in between, and then the second interval, negative 3 to positive infinity, and this represents all real numbers except for negative 3. So that is the answer to question number 1. Let's now have a look at question number 2. G of x is equal to 2 divided by x squared minus 4. So step 1, set the denominator equal to 0. And then solve for x. So we'll start by adding 4 to both sides, giving us x squared is equal to 0 plus 4, which is 4. And now to remove this exponent 2, we want to find the square root of both sides. And the square root of 4 is equal to -2 or +2. So for this domain, it's all real numbers except for -2 and +2. -2 squared would be 4. 4 minus 4 would be 0. And +2 squared would be 4, also leading to 0. So that is why both numbers are included. So the domain, we have one interval from -∞ to -2, a second interval from -2 to +2, and a third interval from 2 to infinity, and parentheses around each set of numbers. So that is the answer to question number 2. Let's now have a look at question number 3. h of x is equal to 2x divided by x squared minus 4x minus 5. The numerator, we don't have any restrictions with this variable x, since let's say we didn't have the denominator, if it were just 2x, there's no number, positive or negative, that x could equal that would make 2x undefined. You would always get a real number if you plugged in negative or positive numbers for this x. So that is why we continue to focus on the denominator in this example, even though we have an x in the numerator. So we set the denominator equal to 0, but now we will need to factor this expression. So we need to find a pair of numbers that have a product of -5 and a sum of -4, and that would be -5 and +1. So x plus 1 times x minus 5 is equal to 0. And now we want to set each factor equal to 0 and solve for x. So x plus 1 is equal to 0. We want to subtract 1 from both sides. So when x is equal to -1, the first factor would equal 0. And if either factor equals 0, then the entire expression equals 0. So in our domain, -1 is not included, since that would make the factor equal to 0. This second factor, x minus 5, is equal to 0. We add 5 to both sides, showing us that we want to avoid x is equal to 5, because that would make the second factor equal to 0. So the domain for h of x, the first interval is from -∞ to -1. The second interval is from -1 to 5. And the third interval is from 5 to infinity. Parentheses around the numbers, since they are not included. So that is how we go about finding the domain of a function when we have a variable in the denominator. Let's now discuss how we find the domain when a variable is in the radicand. The domain of a radical function will have restrictions if there is a variable in the radicand, since the radicand must be equal to or greater than 0. So if we had the square root of +25, that would be equal to positive or -5, both of which are real numbers. But if we tried to find the square root of a negative number, we would get an imaginary number. So remember, the radicand, the number underneath the radical sign, must always be 0 or greater. So if we're looking at a graph, let's say we had f of x is equal to the square root of x. The domain is x is greater than or equal to 0, since, again, the radicand cannot be negative. So it starts at 0 and becomes more positive. But this domain will shift if we add a number under the radical. So the square root of x plus a would shift the domain to -a. Why is that? If x were -a, we would get f of -a is equal to the square root of -a plus a, and that would be 0. So x is greater than or equal to -a. But it cannot be anything smaller than -a, since this would then become negative and then create an imaginary result. So if this shifted, and x were a, we would get the square root of a minus a, which is 0. So x can be greater than or equal to a. So this is how the radicand creates restrictions on the domain, since the radicand has to be 0 or greater. Now the domain of the function will not be affected by a constant on the outside of the radical term, since this will shift the function either up or down. So for f of x is equal to the square root of x, if you add a constant on the outside, this affects the y value. F of x is directly adding c to its value. So at this particular x, it would shift up c amount. At this particular x value, it would shift up c amount. So the entire graph shifts directly up, but it does not shift left or right. That would affect the domain if it goes left or right. But it goes up if you're adding a constant on the outside, and it goes down if you are subtracting a constant on the outside for the same thing. So this again would not affect the domain. Now, one scenario to be aware of is if there is a fraction. To find the domain of a fraction, find the domain of both the numerator and the denominator. The final domain will be the numbers that overlap both sets. So now in this example, we have a radical and a variable in the denominator. So we have to apply both restrictions that we've reviewed. So f of x is equal to x plus 1. In the numerator, there is no restriction. X can be any negative number or any positive number, and you'll get a real number in the numerator. So the domain in the numerator is negative infinity to positive infinity, or all real numbers. In the denominator, we'll have some restrictions. Since x cannot equal negative 2 or positive 2, since both of these will lead to this radical equaling 0. Now a radical can equal 0 if it's in the numerator, but since it is in the denominator, we have to adhere to that rule as well. So this radical has to be greater than 0. So for the domain, it cannot be equal to negative 2 or positive 2, or any numbers between those, since that would then make this radical negative, and we cannot have that either. So since the numerator has no restrictions in the domain, and the denominator has restrictions, then that means the overall domain for the fraction is the part with the restrictions. Since this domain is included in the domain of the numerator and the domain of the denominator, then this is our answer. Okay, so keep this in mind when you're dealing with fractions. The domain will be the x values that overlap both. So let's walk through an example together. Let's say you're asked to find the domain of f of x, which is equal to the square root of x minus 7. Step 1, set the radicand, or the expression underneath the radical sign, to greater than or equal to 0. So we have x minus 7 is greater than or equal to 0. And then we will solve for x. So we do so by adding 7 to both sides, showing us that x is greater than or equal to 0 plus 7, which is 7. So this would be our domain. It can equal 7, so we have the bracket, and that's the smaller value since it is greater than or equal to 7. 7 is the smallest number. And it continues indefinitely, so we have infinity as the second entry here. So that is how we go about finding the domain when we have a variable in the radicand. Let's now have you complete a few practice questions. Question number 1, find the domain of f of x, which is equal to the square root of 2x plus 4. Question number 2, find the domain of g of x, which is equal to the square root of x squared minus 9. And question number 3, find the domain of h of x, which is equal to the square root of x plus 3 divided by the square root of 4x squared minus 36. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. F of x is equal to the square root of 2x plus 4. So step 1, set the radicand to greater than or equal to 0. And then solve for x. So we'll start by subtracting 4 from both sides, showing us that 2x is greater than or equal to 0 minus 4, which is negative 4. And now we want to divide both sides by 2, showing us that x is greater than or equal to negative 4 divided by 2, which is negative 2. So the answer to question number 1, in our domain, the smaller entry is negative 2, with a bracket to the left of it since negative 2 is included. And the larger entry is infinity, with parenthesis to the right. So this would be the answer to question number 1. Let's now have a look at question number 2. We were given g of x is equal to the square root of x squared minus 9. So step 1, set the radicand to greater than or equal to 0. So we have x squared minus 9 is greater than or equal to 0. And now step 2, solve for x. So we'll begin by adding 9 to both sides, showing us that x squared is greater than or equal to 0 plus 9, which is 9. And to get rid of this exponent 2, we want to take the square root of both sides. So this creates a unique case where now we have x is less than or equal to negative 3 and x is greater than or equal to 3. Why is that? If x is negative 3, we'll have negative 3 squared, which is 9, minus 9, which is 0. So that's allowed. The radicand can be 0 or greater. It just cannot be negative. So let's say this were greater than negative 3, but less than 3. So essentially negative 2, negative 1, 0, 1, or 2. 0 squared would leave us with negative 9. So that's not allowed. That would give us an imaginary number. 1 squared would be 1 minus 9, which gives us negative 8. So that's not allowed. And 2 squared would be 4 minus 9, which is negative 5, and that's not allowed. Negative 4, which would be negative 4 squared, which is 16. That would create a positive result and a real number. So our domain is x's that are less than or equal to negative 3, and x is greater than or equal to 3. So our domain, our first interval, is from negative infinity to negative 3, including negative 3, and positive 3 to positive infinity, including positive 3. So that is the answer to question number 2. Let's now have a look at question number 3. H of x is equal to the square root of x plus 3 divided by the square root of 4x squared minus 36. So in the numerator, we have a radical. So we will have a restriction with this expression since we cannot have a negative radicand. So we want to set the radicand in the numerator to greater than or equal to 0. This radical can be equal to 0 in the numerator since you can divide 0 by a number. We just cannot get 0 in the denominator since that would be undefined. So x plus 3 is greater than or equal to 0, and then we solve for x by subtracting 3 from both sides. So x is greater than or equal to 0 minus 3, which is negative 3. So this is the first restriction we're working with. X is greater than or equal to negative 3, so we'll put that to the side. And now we want to focus on the denominator. So we want to set the radicand in the denominator to greater than 0. And then solve for x. So we will add 36 to both sides, showing us 4x squared is greater than 0 plus 36, which is 36. And now we get rid of the coefficient 4 by dividing both sides by 4, showing us that x squared is greater than 36 divided by 4, which is 9. And now we take the square root of both sides to get rid of this exponent 2, giving us the square root of 9, which is positive 3 and negative 3. So we will get x is less than negative 3. Since we're squaring it, Negative 3 squared would give us 9. Positive 3 squared would give us 9. Negative 4 squared would give us 16. Positive 4 squared would give us 16. But we cannot use numbers that are greater than negative 3 or smaller than positive 3. So the numbers between. So for example, 2 squared would be 4. 4 times 4 would be 16. 16 minus 36 would give us negative 20. And we cannot get a negative radicand. So now we have 3 different restrictions that we are working with from the numerator to our denominator. So what we want to do to figure out what our domain is for this one, we want to use a number line to see where these overlap. So our first domain, negative 3 to positive infinity, we plot that on a number line. Then our second portion of a domain is from negative infinity to negative 3, but not including negative 3. So that's here. Got the blue here, have the gray here for the first domain. And now the third portion, we have from 3 to positive infinity, but not including 3. So that's here. So this domain is for the numerator, negative 3 to positive infinity. And then in the denominator, the domain is broken up into 2 parts. This first part from negative infinity to negative 3, but not including negative 3, does not overlap at all with the domain from the numerator. But this portion of the domain from the denominator, because these both came from the denominator, this portion of the domain in the denominator here does overlap this portion of the domain in the numerator. So from 3, but not including 3 to positive infinity, that is where our overlap exists. So that is the domain to h of x. So that is how we go about finding the domain when we have a variable in the radicand. Let's now discuss the range of functions. The range of a function that is a linear expression will be negative infinity to positive infinity as long as the slope of the line is not equal to 0. So f of x is equal to mx plus b, the standard form of a line. The range will be just b if we have a flat line. It's just this number. But as long as there is some slope to it, whether it's positive or negative, the function will continue to positive infinity in the positive direction and negative infinity in the negative direction. So if you are given just a line, the range will be from negative infinity to positive infinity as long as the slope is not 0. So let's look at the range of a radical. The range of a function that is a radical expression will be determined by the sign in front of the radical term and the constant added outside of the radical term. So let's say this were f of x, and f of x is equal to the square root of x plus a. The range is from 0 to positive infinity. This will continue up and up and up. But if there is no constant on the outside, the radicand can be equal to 0 or greater. So 0 is included. But the radicand cannot be negative since that will result in an imaginary number. It can be 0 or greater. So the range is from 0 to positive infinity. But let's say we decided to add a constant on the outside. If we add a constant c, this c directly affects the y value. You're just adding c. So this shifts up c amount. So now the range goes from c instead to positive infinity, since this is shifted as a result. So when you have a radical with a constant on the outside, whether it's positive or negative, the constant on the outside determines where your range begins. Okay, and that number is included, and then it goes to positive infinity as long as the sign in front of the radical is positive. If the sign in front of the radical is negative, and it goes from 0 to negative infinity. So the range would be from negative infinity up to 0, and 0 is included. Since 0 is the high point, it is the last entry. So that is how the sign in front affects the range. If it's positive, the function is going up. And if it's negative, the function is going down. So keep that in mind when you are evaluating the range of the function of a radical expression. Let's walk through an example together. Let's say you're asked to find the range of f of x, which is equal to the square root of 2x minus 1 minus 4. Step 1, evaluate the sign in front of the radical. It is positive, so that lets us know the function is going to be going upwards towards positive infinity. And then step 2, evaluate the constant outside of the radical, which is negative 4. This is where the range will begin. So the range is from negative 4 to positive infinity. So that is how you would find the range of a function that is a radical expression. Let's now have you try a few practice questions. Question number 1, find the range of f of x, which is equal to the square root of negative 3x plus 5. Question number 2, find the range of g of x, which is equal to the negative square root of 5x minus 1 minus 3. And question number 3, find the range of h of x, which is equal to negative square root of negative 7x plus 7 minus 7. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. F of x is equal to the square root of negative 3x plus 5. So step 1, evaluate the sign in front of the radical. It is positive. So we know the function is going to be trending towards the positive infinity as the high point. And then step 2, evaluate the constant outside of the radical. It is positive 5. So this is where the range will begin. So the range for f of x is from 5 to positive infinity, including 5. So that is the answer to question number 1. Let's now have a look at question number 2. We are given g of x is equal to negative square root of 5x minus 1 minus 3. Step 1, evaluate the sign in front of the radical. It is negative. This lets us know that the function is flipped and it is going to trend down towards negative infinity as the low point. And then step 2, evaluate the constant outside of the radical. It is negative 3, so this is where the high point will be. So the range of g of x is from negative infinity up to negative 3, including negative 3. So that is the answer to question number 2. Let's now have a look at question number 3. H of x is equal to negative square root of negative 7x plus 7 minus 7. Step 1, evaluate the sign in front of the radical. It is negative, so we know the function is flipped and it trends down towards negative infinity as the low point. And then step 2, evaluate the constant outside of the radical, which is negative 7. So this is where the range has its highest point. So the range for h of x is from negative infinity to negative 7, including negative 7. So that is how we go about finding the range with a radical expression. Let's now discuss how we find the range of a quadratic that has one or two terms. The range of a function that is a quadratic expression with one or two terms in the expression will be determined by the sign in front of the quadratic term and the constant added. So let's say we had f of x is equal to x squared. This would be that curve. the range is from 0 squared would be 0, so that's the low point, all the way up to positive infinity. This is never negative. Since we are squaring each x, you're always going to get a positive number as a result. So the range is from 0 to positive infinity, including 0. So this is a result of the sign in front of the x squared being positive. That is why it opens up towards the positive infinity. And it starts at 0 since we are not adding or subtracting a constant. But if we were to add a constant, this now shifts up the amount of the constant. So 0 squared would be 0, but we still have the c. So that is why the range starts at c when you add a constant, and the c is included. But if the constant were negative, 0 squared would be 0, so the range begins at negative c, and then still goes up towards positive infinity. So this is the range if you had a number added or subtracted to the quadratic term. But if the sign in front of the quadratic term were negative, that flips the curve upside down. And now we go from negative infinity up to 0, back down to negative infinity. Take the same positive numbers we were getting as a result before, and now we're multiplying them by -1 at all times. So now the range is backwards in a way. It goes from negative infinity up to 0. And just like before, if you add a constant or subtract a constant, the range will shift up to whatever the constant is that's added, or shift down if a constant is subtracted. But that constant is included in the range, whether it's positive or negative. And that constant is the high point since the curve is now flipped. So it is the second entry, with negative infinity being the first entry. Now, one quick note about the coefficient of the quadratic term. The coefficient will make the curve either narrower or wider. But since this will continue indefinitely along the x and the y, it actually does not affect either. Okay? So let's walk through an example together. Let's say you're asked to find the range of f of x, which is equal to 3x squared minus 5. Step 1, evaluate the sign in front of the quadratic. It is positive, so that lets us know that this is going to be opening upwards towards positive infinity as the high point of our range. And then step 2, evaluate the constant, which is -5. So this is where the range will begin. So the range is from -5 to positive infinity, including -5. So that is how we go about finding the range of a quadratic that has 1 or 2 terms. Let's now have you complete a few practice questions. Question number 1, find the range of f of x, which is equal to -4x squared plus 6. Question number 2, find the range of g of x, which is equal to 2x squared over 3 minus 7. And question number 3, find the range of h of x, which is equal to -4x squared over 5 plus 2/9. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. F of x is equal to -4x squared plus 6. Step 1, evaluate the sign in front of the quadratic. It is negative, so that lets us know the function is going to trend down towards negative infinity. And step 2, evaluate the constant, which is 6. So this will be the high point of the range. So the range is from negative infinity to positive 6, including positive 6. So that is the answer to question number 1. Let's now have a look at question number 2. g of x is equal to 2x squared over 3 minus 7. Step 1, evaluate the sign in front of the quadratic. It is positive, so this is going to open upwards towards positive infinity as the high point of the range. And then we want to evaluate the constant, which is negative 7. So this will be the low point. So the range is from negative 7 to positive infinity, including negative 7. So that is the answer to question number 2. Let's now have a look at question number 3. H of x is equal to negative 4x squared over 5 plus 2/9. Step 1, evaluate the sign in front of the quadratic. It is negative, so that lets you know the quadratic is going to trend downwards towards negative infinity as its low point of the range. And then when we evaluate the constant, we have 2/9. So this is the high point of the range. So the range is from negative infinity to positive 2/9, including 2/9. So that is how you go about finding the range of a function that is a quadratic that has 1 or 2 terms. Let's now wrap up the chapter by discussing how we find the range of a quadratic that is a trinomial. The parabola of a quadratic expression will open upward and have a minimum point when a, or the coefficient in front of the quadratic term, is positive, and will open downward and have a maximum point when a is negative. So we have our curve, and when a quadratic has a positive coefficient, we know that it opens upward towards positive infinity of the range, and then has a minimum point. This minimum point has a coordinate of hk. The h is the x value of this point, and k represents the y value at this point. So the range will be from the y value k to positive infinity. And I'll show you why we're using this notation in a second. If we had negative a in front of x squared, the function would flip and would be opening downward towards negative infinity of the range. So this here is a maximum, or it's the highest point of the function. And this maximum point has an x coordinate of h and a y coordinate of k. So the range is from negative infinity all the way up to k. Now, why are we using h and k? H is the x coordinate of the point that we are looking for, and it can be found using this formula. H is equal to negative b divided by 2a. A is the coefficient of the quadratic term, and b is the coefficient of the x term that has an exponent of 1. So the minimum or maximum point of a parabola is called the vertex, and it can be calculated using the coefficients from the expression. So the x coordinate, h, is equal to negative b over 2a. That allows us to find the x coordinate, and then we plug that value into the function, and that will allow us to find the y value at this point. So this y value k will be the low point or the high point of the parabola, and thus the range. Let's walk through an example together. Let's say you were asked to find the range of f of x, which is equal to 3x squared minus 4x plus 3. So we want to use the coefficients to first calculate h. So we have h is equal to negative b over 2a. So b is negative 4, and a is 3. So now we can simplify this to find h. Negative times a negative is positive. And we have 4 over 2 times 3, which would be 6. 4 over 6 can be simplified to 2/3. So we have h is equal to 2/3. So now we want to solve for f of h, and h is 2/3. So we'll plug that in here for our x's. So that would give us f of 2/3 is equal to 3 times 2/3 squared minus 4 times 2/3 plus 3. So that gives us 2/3 squared, which is here. This 3 is technically in the numerator, so we can cancel out one of the 3's in the denominator, so we'll cancel out this one. So that leaves us with 2 times 2, which is 4 over 3. And now for the second term, we have negative 4 times 2, which would give us negative 8 over 3. So since both of these terms have a denominator of 3, we want to change this third term to a denominator of 3 so that we can simplify the expression. So 3 is equivalent to 9 over 3. 9 divided by 3 gives us 3. So now we can combine the terms. 4 minus 8 is negative 4, plus 9 would give us 5 over 3. So f of h is equal to k, or the y value we are looking for, and that's equal to 5/3. So now that we know that k is equal to 5/3, we can find the range, but we first want to evaluate the sign in front of the quadratic, and it is positive. So that lets us know that the quadratic is opening upwards towards positive infinity as its high point of the range. So the range is from 5/3 to positive infinity, including 5/3. So that is how you go about finding the range of a quadratic that is a trinomial. Let's now have you try a few practice questions. Question number 1. Find the range of f of x, which is equal to 2x squared plus 6x minus 1. Question number 2. Find the range of g of x, which is equal to negative 3x squared minus 6x plus 9. In question number 3, find the range of h of x, which is equal to negative 5x squared plus 10x plus 4. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. F of x is equal to 2x squared plus 6x minus 1. So we are first going to calculate h using the coefficients 2, which is our a, and 6, which is our b. So h is equal to negative 6 over 2 times 2, which is 4. Negative 6 over 4 can be simplified to negative 3 over 2. And 3 over 2 is 1.5. So we get h is equal to negative 1.5. So now that we know h, we can solve for f of h, or f of negative 1.5. So we plug that in for x into the function, giving us 2 times negative 1.5 squared, which is 2.25, plus 6 times negative 1.5, which is negative 9, minus 1. 2 times 2.25 is 4.5. 4.5 minus 9 is negative 4.5. Minus 1 is negative 5.5. So our k is equal to negative 5.5. So this is the y value we are looking for. And now step 3, evaluate the sign in front of the quadratic. It is positive. That lets us know the quadratic is opening upwards towards positive infinity as its high point of the range. So the range is from negative 5.5 up to positive infinity, including negative 5.5. So that is the answer to question number 1. Let's now have a look at question number 2. G of x is equal to negative 3x squared minus 6x plus 9. Step 1, calculate h using the coefficients, negative 3, which is our a, and negative 6, which is our b. Negative 1 times negative 1 will give us positive 1. So we wind up with a negative from this negative. And we get 2 times 3, so we get 6 in the denominator. So we wind up with negative 6 over 6, which is negative 1. So now that we know h is equal to negative 1, we can solve for g of negative 1. So we plug negative 1 in for x, giving us negative 3 times negative 1 squared, which is positive 1, times negative 3, which is negative 3. Negative 6 times negative 1 is positive 6, plus 9. Negative 3 plus 6 is 3. Plus 9 would be 12. So we get k is equal to 12. So we need to evaluate the sign in front of the quadratic. And we see that it's negative, which lets us know the quadratic or the function is going to trend down towards negative infinity as its low point. So once we know the graph is going to open downward towards negative infinity as its low point, and we have 12 as its high point of the range, that lets us know the range is from negative infinity to positive 12, including positive 12. So that is the answer to question number 2. Let's now have a look at question number 3. h of x is equal to negative 5x squared plus 10x plus 4. So we are first going to use the coefficients negative 5 and 10 to calculate h. So h is equal to negative 10 over 2 times negative 5, which would be negative 10. This negative and this negative cancel each other out. So we get 10 over 10, which is 1. So now that we have h is equal to 1, we want to find h of 1. So we plug in 1 for x, giving us negative 5 times 1 squared, which is negative 5, plus 10 times 1, which is 10, plus 4. Negative 5 plus 10 is positive 5, plus 4 would be 9. So we know k is equal to 9. So now we want to evaluate the sign in front of the quadratic, and it is negative, letting us know the function will open downward towards negative infinity as its low point, and 9 as its high point of the range. So the range for question number 3 is from negative infinity to positive 9, including positive 9. And that wraps up this chapter on functions. Should you have any follow-up questions, feel free to leave them in the comment section. Or you can find a tutor in your neighborhood by visiting bookandtable.com or by downloading our app on the App Store. Peace.